In Part 2 of Lecture 7, we will discuss packets and Internet addresses. A packet is a small amount of data. Packets are sent across a computer network, independently of any other packets that comprise the message. This proves to be more flexible and makes it much easier for the network to be adaptable. Since packets travel independent of each other, they can and often will be routed differently from each other. This means that if a path through the network is not functioning, or if there is too much data trying to make it through that path, the other packets may take a different route. Packets then can be reassembled at the destination. One reason that this works is because while messages can be a single line of text or an extremely large file, they all get broken down into packets of the same size. The message is broken down by the sender, with each packet numbered and indicating how many packets there are, and they are reassembled by the receiver. Their numbers allow them to be placed back into the correct order, even if they are received in the wrong order. And the receiver can request that a particular packet be resent if it was never received. There are two ways in which messages can be transmitted over a network: circuit switching and packet switching. In a circuit switching network, a circuit is established connecting the two nodes. Any communication that they have uses that circuit, which is theirs until the communication session closes. Circuit switching is what the telephone systems have used traditionally. In a packet switching network, the message is broken down and sent independently through the network. It is not dependent on any particular channel or circuit. This is extremely helpful if you are dealing with large messages. The Internet is highly dependent on two core protocols: IP, the Internetwork Protocol that handles addressing, and TCP, the Transmission Control Protocol, which is responsible for dividing messages into the smaller units we know as packets. TCP is responsible for providing the necessary information so that messages are reassembled correctly on the other end. This includes making sure that there are no errors created in the data, something that can happen by accident in the transmission process. This is known as error checking. There is another protocol that we can use in place of TCP. It's called User Datagram Protocol, or UDP for short. UDP is faster than TCP. However, it does not perform error checking, and it cannot reorder packets. So therefore, while it may be faster, it is not as reliable as TCP. As we discussed before, Internet addresses are handled by IP, the Internetwork Protocol. IP addresses are numbers which are assigned to nodes on the Internet. Many of the devices on the Internet are assigned IP addresses that are, for all intents and purposes, permanent. These are called static addresses because they do not change. The standard for IP defines two different sets of addresses: IPv4 and IPv6. IPv4, which is Internetwork Protocol version 4 uses 32-bit addresses to identify Internet-connected devices. The only problem is that this leaves us with a limit of a little more than 4 billion addresses. As we have seen, the growth of the Internet means that we need more than 4 billion addresses. For this reason, there is now IPv6, Internetwork Protocol version 6, which uses 128 bits for each address, giving us billions of unique Internet addresses. Not every computer keeps the same IP address. This is especially true on larger networks to which computers are connected and from which computers are disconnected. A dynamic IP address is assigned to a computer or similar device when it is connected to the network. The assignment of a particular address is handled by the DHCP server. DHCP is short for Dynamic Host Configuration Protocol. Many local area networks use TCP and IP as protocols for their network. This requires that any computer on the network have an IP address, or it can't use the services of the network. If this address was not allocated under the supervision of ICANN, it is a private IP address. While it can be used within the local area network, it cannot be used to send data over the Internet, because there would be no way to route it through the Internet. This is where a router comes in. The router has a public IP address that it can use to route data through the Internet. In the example that you see in the slide, someone is trying to buy a copy of Michael Jackson's song Thriller. The router records the private IP address of the computer looking to make the purchase. The request is forwarded using the router's public IP address. When the reply comes, it reaches the router, which recognizes the computer to which the response goes. The private IP address is attached to it, and it can reach the purchaser.